Good morning, everyone. Good morning. Welcome to the MIT Water Summit. In 37 BC, King Herod built a fortress in the Judean desert and called it Masada. On that majestic plateau, surrounded on all sides by scorched sand and rock, Herod constructed one of the most advanced water systems of its time. A sprawling network of dams, channels, and cisterns to alleviate thirst and grow food on that ancient summit. In 2011, I ascended that summit, took a few selfies, and climbed back down. And when I reached the bottom, I did more than tweet the photos to my 12 followers. I reflected on what I had seen that day, and I began to think about water differently. I've been thinking about water, the resource itself, and the systems that deliver it differently ever since. For centuries, we have moved and shaped the earth, directed vast amounts of labor and capital to bring clean water to people throughout the world. And in the face of new challenges and new risks, we will continue to find efficient ways to bring water to people and to use water more responsibly. Welcome to the 2014 MIT Water Summit. My name is Adam Weiner, and we have a fantastic program for you today. The Water Summit is run by a small but dedicated team of students. I want to thank all of my teammates, as well as all of our volunteers and sponsors for their time, energy, and passion for this event. Together, we are invigorating current research and inspiring new collaborations in water technologies and policies. This is the MIT Water Summit.
Is huge. It's really our livelihoods, it's our health, it's our economies.
We know that there are more than 1 billion people who lack safe water in the world.
If you don't have energy, we can still live. If we don't have water, we cannot.
Right now, you turn on the tap and you don't even think about it.
I think it's important to develop, especially among our students, our community, some critical thinking about these issues.
It's actually important for all scientists and engineers from all disciplines to be asking themselves how it is that their expertise could be brought to this problem of clean water.
I'm totally impressed with this generation of students in their commitment to addressing poverty and inequity in the world.
Climate change, population growth, increased urbanization are posing significant risks to the renewable water supply around the world. And any way that, not just technologists and engineers, but also policymakers, entrepreneurs, investors can try to mitigate those risks would do our Earth and our humanity a real service.
Water supply is under a great deal of pressure, and yet most of the Earth's surface is covered with water. And so if there is a way for us to make that water usable, drinkable, or good for irrigating crops, then we can help to relieve the pressures on water supply worldwide.
We're already seeing countries like Israel, countries like Saudi Arabia, leveraging the technology of desalination to supply clean drinking water to their populations.
The research that we're doing is more about how you loop back water systems. So it's not so much a linear approach as it is a cyclical approach where water is being used, it's also being cleaned and treated, and it goes back into the system, as opposed to being put back into an ocean where we can't really get it back without great effort and cost.
The hardest problems today in energy and water are inherently multidisciplinary. And a summit like this allows people from different walks of life to come together who are interested in this problem and think together about it and learn about what's going on across the disciplines and get new ideas and get inspiration.
kind of galvanizing the water community on campus.
I want to begin the summit by thanking our sponsor, the Abdul Latif Jameel World Water and Food Security Lab. The lab is directed by a professor who believed in our team when the Water Summit was just an idea, and who has pushed us and supported us all along the way. Let's give a warm welcome and a gracious thank you to Professor John Lienhard.
Thank you all, and thank you for coming today. I'm really looking forward to the program that's ahead. I think we've got a great lineup of speakers and some very interesting things to hear and to participate in today. MIT has been involved in water really since very near its founding. Our first female graduate and first female professor was named Ellen Swallow Richards, and her work focused on water quality. She took water samples from around the Commonwealth of Massachusetts, over 20,000 sites, which eventually led to the development of the very first water quality standards that were implemented in this country. MIT continued this work over the coming century, and work in water quality, water supply, and sanitation continued over the century that followed. And really, at least in the context of the US, we did really well, to the point that the US National Academy of Engineering, when it summed up the greatest 20 accomplishments in engineering for the 20th century, listed water and sanitation systems as one of them. There's a certain finality to a list like that, as if somewhere around 1960 a box had been checked off. We're done, we solved the problem. But look at how the world has changed. In 1960, our population was about 3 billion. Today it's more than 7 billion. By 2050, it will be 9 billion. 3 times the number of people being supplied from the same natural, renewable source of fresh water, which is rainfall over land. That's not rising in parallel. And so the strain on water supply is growing rapidly as this occurs. Urbanization is another factor. It was mentioned in the video. Today, more than half of the world's population live in cities. By 2050, more than 70% will live in urbanized areas. And so the problem of delivering water to people in cities has taken on a renewed character and a renewed urgency. With all this growing population, there's an increased demand for food. It's estimated that by 2050, demand for food worldwide will rise between 50 and 70%. And that as well requires more water for irrigation of crops and more strain on the system and more thought as to how we're going to meet these needs. And then beyond that, we have the problem of climate change and a warming planet, which affects both the productivity of food and the availability of fresh water to all of us. So the problem is not solved at all. The problem is, in fact, changing and becoming, in many ways, more difficult than it was back at mid-century. MIT has been thinking about water, as I mentioned, for a very long time. And more recently, we've been looking at how we can coordinate our efforts in water and magnify the things that we're each doing individually across various departments and schools. And this year, through a gift from one of our alumni, Mr. Mohammed Jameel, we have established the Abdul Latif Jameel World Water and Food Security Lab, which operates with the aim of bringing together MIT faculty from all disciplines to work on these multidisciplinary issues of water supply and food security. And in particular, with the aim of trying to take our knowledge, our graduates, our expertise, and translate that to the outside world in a way that can materially affect other people and resolve these problems for people worldwide. Today we're going to hear about 3 slices of these problems. We will have a panel on water and food, be our first panel. Our next panel will be about water in cities, and our next panel will be about water and industry. Each of these are slices of the very complex problem of water, and there are many other dimensions that we could bring into this if we wanted. Water and energy, water and poverty, water and development are also topics, perhaps for a future summit. But with that being said, again, I'm very happy that you're all here today. I'm really looking forward to our speakers and the conversations that will ensue. and I hope that you all enjoy this event. Thank you.